Hello everyone. In this video, I will explain to you about the MATLAB's 5G toolbox. Okay, and these uh, codes, these are given by MATLAB for generation of a downlink signal, and you can see the link there on my description. You can check it out. So first, then for a non professional, this one is a bit difficult to be understood, so I will explain you the basics of 5G along with when I'm explaining this video. Okay, so the first thing we have to know is this carrier configuration part. Okay, this carrier configuration part, you first define what the total bandwidth of your 5G signal is. Okay, and first things first, in 5G, okay, there are different subcarrier spacings allowed here. So you can have either 15, 30, 60, 120, 240 or 480 kilohertz of subcarrier spacing. Okay, all right. So in this one, you have to define how many or what is the bandwidth of your signal, of your 5G signal. And another term that is used in 5G is something called NBLRD. This corresponds to number of downlink resource blocks. All right. So in 5G, one resource block, that is 1 RB, corresponds to 12 resource elements, and each resource element corresponds to 15 kilohertz. So this would mean that one resource block means 180 kilohertz. All right. So in this one, you are defining how many resource blocks total you have. So in this case, if you have 200 resource blocks, that means you have 200 into 180 kilohertz, which comes around 36 megahertz. So in here, you have to define what's the bandwidth of your signal in 15 kilohertz subcarrier spacing. Okay, so for this example, we have 236 megahertz of bandwidth, and then this cell ID part, you don't need that right now. We will use that later. But the other important thing is this number of subframes. Okay, so again, everything you should remember is the cornerstone is the 15 kilohertz of subcarrier spacing. All right, and everything 30 kilohertz, 60 kilohertz, they are just multiples of this 15 kilohertz. So in 15 kilohertz, okay, actually, one thing you should know before that is one frame in 5G is 10 milliseconds. All right, and similarly, one subframe corresponds to 1 millisecond. So in 1 millisecond, you transmit one subframe, and in 15 kilohertz, okay, one subframe corresponds to 14 OFDM symbols. Okay, and that means for 10 millisecond or one frame, you submit how much? Yes, you submit 14 into 10 OFDM symbols. Okay, so for one frame, that means you transmit 140 OFDM symbols. Okay, and similarly, this is for 15. So another thing you should know is that for 30 kilohertz of subcarrier spacing, the number of OFDM symbols per subframe will double. Okay, so it would be 14 into 2, that is 28 OFDM symbols. Similarly, for 60 kilohertz, it would be 28 times 2, that is 56 OFDM symbols. And another terminal term that you need is something called slot. Okay, so for 15 kilohertz, okay, I'm using 15 instead of typing kilohertz, everything, the subcarrier spacings are usually talked in kilohertz. So 15, one subframe corresponds to one slot. All right. For 30, one subframe corresponds, because if you remember, for 15 kilohertz, if you have 14 OFDM symbols per subframe, but for 30 kilohertz you should have how many total? 28 OFDM symbols. That means in here the number of slots is double, that is it's two slots. Okay, and for 60, you should guess by now, one subframe corresponds to 4 slots. Okay, this is an important terminology that you need for this. All right, and this one, this carrier dot display grids, this just shows in a figure what our frequency allocation is. Okay, I will show it to you later. Okay, then you come to this SS bus. So in here, SS means synchronization signal. Okay, usually for just to see how to generate a 5G signal, you don't need to change anything here. You don't need to do anything here. All right, and then next important part is this something called the bandwidth parts. Okay, all right. Okay, then to explain what this bandwidth parts mean, in here you can see this bwp.png, and let us open this in MATLAB using the command imshow bwp.png. Okay, then this opens up something like this. Okay, so this part, the blue part, corresponds to one bandwidth part, and this green one corresponds to another bandwidth part. Okay, so one thing you have to know is that for each bandwidth you have to define what the subcarrier spacing is. That is, it can be 15, 30, 60, 120, 240, 480 kilohertz, kilohertz, and then also CP means this cyclic prefix. So what cyclic prefix is? Usually there are two cyclic prefix lengths, one normal and one extended, and usually we need the normal one because the extended one we don't use it anymore. Okay, all right, so you define the bandwidth part from this dash line, if you can see. Okay, so first you have to define for the first bandwidth part how much is the offset from this dash line. Okay, this one, and this you have to know the y-axis is the number of resource blocks, and this corresponds to the time axis. Okay, so in this one we show that okay, bandwidth part is at an offset of this much. Okay, and then this one, this the total length in resource blocks, it corresponds to how many resource blocks are defined for this bandwidth part. So another additional parameter you need apart from the subcarrier spacing and the cyclic prefix is how many resource blocks you allocate for this particular bandwidth part. Similarly for this one, you define an offset. Okay, this is the offset, and then how many resource blocks you allocate for this, and then you have the second bandwidth part, and this total, okay, this is the total bandwidth of your signal. If you remember from the earlier explanation, this corresponds to 36 megahertz or 200 resource blocks in 15 kilohertz subcarrier spacing. So similar to the definition of the carrier, you define BWP to denote bandwidth part, and this is the bandwidth part 1 and this is the bandwidth part 2. Okay, so for the first bandwidth part, your subcarrier spacing is 15 kilohertz and your cyclic prefix is normal. Okay, and then you define the number of resource blocks to be 25. Okay, number of 20, that means if you remember, one resource block is 180 kilohertz, so 180 kilohertz into 25, this much of bandwidth we are defining for the first bandwidth part, and the resource block offset is 10. That is, from 0 this goes 10 up, if you remember the image earlier. So that means it's starting from the 10th resource block and goes up to 35, 10 plus 25, 35 resource blocks. Okay, similarly you can see for the second bandwidth part. In here the difference is now the subcarrier spacing is 30 kilohertz and the cyclic prefix is normal and the number of resource blocks is 30. So can you guess what the bandwidth is? Let's see. In here one resource block corresponds, because if you remember, one resource block, it's 12 resource elements. Okay, so in this part, since the subcarrier spacing is twice, now it's 360 kilohertz. That is, one resource block corresponds to 360 kilohertz, and you have 30 such resource blocks. So in this case, this is the total bandwidth of the second bandwidth part. And here the resource block offset is 70. That means from 0 to 70 it's the resource block offset, and then you go 30 resource blocks up, but it should be in 30 subcarrier spacings. Okay, so that corresponds to the image which you saw earlier. And this this part of the video I will conclude this here with, let us run this one and see what the result would show. And let's see. So one thing to note is that the first figure generates something like this. If you run the file, it shows bandwidth part in carrier and bandwidth part 2 in carrier. If you remember, carrier, it shows the total number of bandwidth the 5G signal has. Okay, and the subcarrier spacing, this one, for the first one we define as 15 kilohertz, and for the second one we define as 10 kilohertz, and for now you don't need to consider about these ones. Okay, so you can see for the first bandwidth part we define some resource block offset of 10, so that corresponds to here, and then this part is the bandwidth of the bandwidth part 1. Similarly, for this one we define a resource block offset of 70, and this part corresponds to the bandwidth part 2's bandwidth. All right, and since we have defined 10 milliseconds or 10 subframes, this corresponds to 140 OFDM symbols in carrier 1, whereas it's 280 for subcarrier spacing of 30 kilohertz. Okay, all right. And for the second one, you can see this is the same as the first one, but now the y-axis is in subcarriers instead of resource blocks. Okay, so in this one the only difference, because in the first figure it shows the locations of different, for example, the PDSCH, PDCCH, and the cosets, which I will talk in the next video, but this shows everything in some power scale. Okay, this is just for illustration purposes. You just need to take an idea. Okay, this part is empty, but these contain some power. That means these have some symbols defined on them. All right, that's it for the first video. So if you have any comments or questions, please write them in the comment section and I will reply to you, and I will also get back to you from the second video. Please subscribe and share and let me know what I can do to improve more. Thank you very much.